Hello everyone, in this video we are going to learn all the important formulas of chemical kinetics, especially zero order and first order reaction. Okay, when we talk about zero order reaction, rate is directly proportional to the concentration to the power 0. It means rate is independent of the concentration of reactant, whereas unit of K is what? A mole per liter per second. Okay, and expression of K is what? K is equal to R naught minus R by T, where R naught is what? Initial concentration, R is what? Final concentration, and T is the time. And half life period T half is equal to R naught by 2K, where R naught is what? Initial concentration, K is the rate constant or velocity constant. When we talk about the first order reaction, here rate depend upon what? 1 power of the concentration of reactant. So rate is directly proportional to the R to the power 1. Unit of K is what? Second inverse. Expression of K is equal to 2.303 by T log of initial concentration by final concentration, R naught by R, yes or no? And half life period T half is equal to 0.693 by K, yes or no? Okay, you should remember if initial concentration A is there and how much percentage it is decomposed, X is given, so we can apply this formula. K is equal to 2.303 by T log of A upon A minus X. A minus X is what? A final concentration, and A is what? A initial concentration. Okay, one result you should remember, time required for 99.9% completion for a first order reaction is what? A 10 times of T half. Okay, directly we can substitute the value and we can get the answer. Here we talk about the graph. Okay, for zero order reaction, concentration versus time. Okay, this is the graph, time versus concentration. Log of A versus time for first order reaction, this is the graph. Okay, this x-axis is what? Time, and y-axis is what? Log of A. Okay, for second order reaction, this is the graph, time versus 1 by A. Okay, here time versus 1 by A square for third order reaction. Similarly, plots from integrated equation, okay, rate versus concentration, it is like this. So rate is independent of the concentration, yes or no? From this graph you can see. Okay, for the first order reaction, it is directly proportional. Rate is directly proportional to the concentration. Okay, and rate and concentration square, it is directly proportional. For second order, rate and concentration square, it is the concentration to the power 3, rate is directly proportional, yes or no? Similarly, graph between T half and concentration. T half and concentration for zero order reaction is directly proportional, yes or no? From the expression we can see T half is directly proportional to the initial concentration. Okay, and for first order reaction, T half is independent of the initial concentration. So if whatever the concentration is there, T half is constant, yes or no? For second order reaction, T half versus 1 by concentration, graph is like this, and T half versus, or we can say like this also. Okay, it is inversely proportional to the concentration. Okay, one note you can remember, T half is directly proportional to the initial concentration to the power 1 minus n. If you put n is equal to 0, you will get, okay, this. If you get n is equal to 1, you will get this. Okay, T half is independent of the concentration, yes or no? Like that. Next we have a Arrhenius equation. Okay, K is equal to A into e to the power minus EA by RT. Okay, where K is what? Rate constant, A is what? P exponential factor. Okay, and EA is what? Activation energy, R is the gas constant, T is the time. Okay, and if the two different temperatures are given and two different rate constants are there, so we can apply this formula to solve the numerical. Okay, log of K2 by K1, okay, is equal to EA upon 2.303 R whole into T2 minus T1 by T1 T2, where T1 T2 are the temperatures, K2 K1 are the rate constant at the two temperatures. I hope you understood all the formulas. Okay, one basic formula you should remember when we talk about the rate. Rate is nothing but minus delta R by delta T, that is decrease in concentration of reactant, or plus delta P by delta T. Please practice all the formulas. If you like this video, please share this video with your friends. Don't forget to subscribe the channel. Thank you.